Hello, everybody. Hope you're doing great. Uh, Today, we are going to talk about a very important phenomena related to momentum uh, that we call it collision. Usually, when we uh, listen the word collision, we consider it may be a bump, crash, or impact, or sometimes we can say it's a hit, like you can see in the figure. But in physics, whenever we use the word uh, collision. So we have to say the two object in an event or two or more object when they get closer to each other enough that they exert forces on each other for a very short interval of time. When these objects exert forces for short interval of time, there might be a change in uh, momentum, change in kinetic energy, maybe there is something lost, something gained. So we have to consider this as a collision. So for a simple scenario, collisions are the impacts or the event in which forces are applied on the objects from one to another for very short interval of time. The second thing that we need to understand is a system is uh, when two or more interacting objects are related to each other, like this is a railroad car and it is hitting a blue one is hitting to the red one. So we are considering this is a collide these are the colliding object. In collision, we just need to remember a system when it is isolated, which means that there is no external force. I'm talking about net external force acting on them. That internally these objects are applying force on each of them, but none of the external agents is working on it. So if a system which have no external agent or sum of all the forces acting externally is zero, then we say that the system is an isolated system. So when you consider an isolated system, it means you have to ignore all of the forces acting on it. That will be force of friction, gravity, and the other, but only we will consider that these objects are applying forces on each other during the collision. So in this case, change in momentum of one object will be equal and opposite to the change in momentum of the other object. So this thing we have to remember during the system's collision it happened. Whenever we consider this system, so actually we are going to ignore other forces like friction, thrust, etc. So these forces are uh, making the system as we say that this system is isolated system. Okay, let us consider another very important thing that is called law of conservation of momentum. So whenever we consider law of conservation of momentum, we have to talk about a very important thing. That let us say we have a system of two objects, like one object having mass ma and moving to the right with velocity va, another has mass mb and it is also moving to the left with velocity vb. They both collide, they hit each other, and the force of object A on B is equal to force of object B on object A. Both of these forces are equal, but both of these forces are opposite to each other. So these forces are equal and opposite. When these forces act, their speed changes or velocity changes, they move on the different direction. So law of conservation of momentum in these type of cases says that the total momentum of the system we are talking about isolated system. Total momentum, you know that P stands for momentum. Total momentum of an isolated system remains conserved. Whenever we use the word conserved, it means that it is same. Total momentum of an isolated system remains conserved. So when you say the word conserved, it means that we can say total momentum of an isolated system before the impact, before the event, or before the collision will be equal to total momentum of an isolated system after the collision. So whenever we are talking about total momentum before collision is after, so in this scenario what we got here is total momentum before collision is this case. So in this system we have two objects. So total momentum of these two objects, we can say total momentum of object A plus total momentum of object B before collision will be equal to total momentum of object A after collision. So to differentiate from before, I just wrote P prime, and after collision of total momentum of object B is this. So this case can be momentum of the first MA VA and the second object MB VB will be equal to MA VA prime plus MB VB prime. So this is called law of conservation of momentum, that for an isolated system total momentum before is equal to total momentum after. This is before systems collision and this is after the collision. In this you have to remember that this is an isolated system. Okay, this is one way to write law of conservation of momentum, but I would like to initiate another thing that is very, very important when you say law of conservation of momentum, so you have to fix one thing: the system is isolated, sum of external forces is zero, there is the event collision explosion, total momentum before is equal to total momentum after. This thing that I wrote here, total momentum before and total momentum after, I use MAVA and VA prime, VB prime for after. There is a better way to write it if you consider that this is an object that has, let's say we can say mass is m1 and it is moving with velocity v1I. V1I is the velocity of the first object that is heading toward another object having mass m2 and its initial velocity is v2I. I stands for initial. Both of these collide. When these both objects collide, they apply forces equal and opposite. So the first object, which was having mass m1, move with velocity v1f, and the other object that was having mass m2 moves with some velocity v2f. So it, I think it would be more easy to understand. So before the collision, as you know, before colliding, the system's total momentum was momentum of the first m1 v1I plus m2 v2I for the second one, and after the collision the total momentum of the system will be m1 v1f plus m2 v2f. So this scenario, when we consider as a law of conservation of momentum, total momentum before becomes equal to total momentum after the collision. Okay, here we are done with the very important scenario about the collision and momentum, that the momentum of a system before and after remains same. So to understand it further, let me talk about a very simple situation in which we have two bumpers car. One bumper car is having mass 150 kilogram and it is moving with positive 10 meter per second. Let's say right side is a positive. It collides with a stationary 200 kilogram bumper car. After the collision, 200 kilogram bumper car moves forward, uh, whatever forward direction you consider. Initially, it was stationary, now it moves forward. So, we consider forward direction as positive, so it will move in that direction. So, what is 150 kilogram bumper car's velocity after the collision? So, if we start this situation by drawing, so what do we get? So, here we have to start with the first one. Let's say we have this bumper car. I'm just trying to make it. This is the simple car, and this car is moving forward with 10 meter per second, 10.0 meter per second, because it's first car and its initial velocity, its mass, as we said, that m1 is 150 kilogram. Okay, whereas the other car, that is 200 kilogram, it is somewhere here. We can say that this is 200 kilogram car. It is having mass m2, and m2 is 200 kilogram. This is not moving, so its initial velocity is zero. It's not moving in any direction. Now, what they are saying, when these two collide, so what happens after collision? 2 kilogram bumper car moves forward. 1 kilogram bumper car's velocity after the collision. I just suppose that after the collision, this is 150 kilogram car having mass m1. It's moving in same direction. For example, I just say same direction. I don't know if either it's moving forward or either it is moving backward. Whatever it is, we have to find what is v1f. On the other hand, we know one thing, that when we hit this car with the second car during the collision, during their impact, the second car, having mass of 200 kilogram, starts going forward with the final velocity of 8.57 meter per second. So here in this situation, we have to think wisely that what's going on, that first car either stops, first car either moves forward or backward, we don't know, but the second car is going forward. So using law of conservation of momentum, we are very well aware by conservation of momentum. What conservation of momentum says? By using conservation of momentum, total momentum before the crash or before the collision will be equal to total momentum of system after the collision. So as we wrote earlier on, total momentum before is m1 v1 and m2 v2 but after collision is m1 v1f plus m2 v2f. By the way, if you like MAVA and MBVB, MAVA, and so it's up to you, that's not a big deal. So we just substitute the values. 150 times 10 plus 200 times 0 gives us 150 times the unknown v1f and 200 times 8.57. Here I would like to mention, if they say that the second car moved backward, then if we consider forward as positive, then backward will be negative. So here in the first side, total momentum before is 150 times 10, that is 1500 plus 0 is equal to 150 times v1f, this is as it is, plus 200 times 8.57, it is going to give us 200, what I get, 1714. So I can just simply say 1500, and this 1700 moves on the other side, so it will be subtracted. So this will be 150 times V1F. So negative 214 is equal to 150 times V1F. So this 150 times is divided on the other side to find the V1F. So I can just simply say that 214 divided by 150 gives me 1.4266, so on. So V1F is equal to negative 1.4266 bar, and unit is meter per second. Here we have to consider one very important thing that is very important to understand, that we got our answer. First of all, we need to convert it into three significant figures, so I have to write answer up to 1.42 will change to 3. Secondly, this negative sign means that this car, 150 kilogram, which is less in mass than the other, after hitting, recoils backward, moves backward. That will be written as that this is 1.43 meter per second in the backward direction. So this will be going back in the backward direction. So this is very important thing that we need to remember. Okay. So what we found from this whole explanation, we found that whenever we have a system, so you need to consider, if it is an isolated system, so collision before and after will be the same. So here the situation is not this one, V1F is this one, that is 1.43 meter per second. Now if you want to check this one, you can consider the total momentum before was 1500. So same momentum will be found by the system after collision. You can just do after collision is 200 times 8.57 and 150 times negative 1.43. So when we will see, it will be done. The similar thing can be explained in this type of example. If you are having these two girls that are pushing against each other, so total momentum of this system before they push was 0, and when they push each other, so both of these girls are moving backward. So both of these roller skaters will again have total momentum is equal to 0. So total momentum 0, how it is possible to understand that? According to law of conservation of momentum, total momentum before, so total momentum before, because both are not moving, is equal to red one is not moving, 0 momentum, white shirt girl is roller skater is not moving, is 0. Whereas total momentum after they push each other, the red shirt girl's momentum plus the white shirt girls momentum, but both of these girls are pushing to each other. So I can say that if this is moving to the left, so I will put negative sign. So when I move this one, the momentum of the red shirt will move on the other side, will be equal to momentum of the white shirt girl, and they are equal. And the other thing, their direction is opposite. So in these type of scenarios, total momentum before will be equal to total momentum after, but both of these momentums will be equal and opposite. So we can just simply say, if you are not putting them negative in the beginning, so you can simply say that this situation, like this is momentum before is zero, momentum after. So you can simply see when momentum before is equal to momentum after, so this will go on the other side and become negative. So the final momentum of this red shirt roller skater will be equal and opposite to the other white shirt roller skater. So there is another scenario that I would like to talk about it. For example, you have a rifle, and in this rifle, what you have a bullet inside it. For example, this is the bullet. So when you did not fire from the rifle, so total momentum before shooting is zero, and when you fire, you feel that this rifle, which is initially not moving, but after fire it will recoil back, and the bullet that is moving forward with very high speed. So when you will find total momentum of the rifle after, that is PR prime or PR final, will be equal to total momentum of the bullet final. Why? Because bullet is very small in mass, but it's going with very quick speed. So momentum is the product of mass and the speed. So you can say momentum of the rifle, how much the mass of the rifle is, it will be equal to momentum of the bullet final, but opposite in the direction. Why? Because if you say the rifle is 100 times more massive than the bullet, then of course bullet will have 100 times more speed to maintain that momentum. So, this is very important to understand, that whenever we have a system, what happens. So, to understand it further, let us see we have two objects, one red billiard ball and one white billiard ball that is moving. White billiard ball is moving toward the red billiard ball, which is initially at rest. So, red billiard ball with mass m is equal to the white billiard ball's mass m. So, I'm not writing 1 or 2, but the final momentum, initial momentum of the red ball was 0. What happens after the collision? You know that the total momentum remains same. So which situation is more likely possible? Both balls move to the right, but red ball moves forward because their masses are same. So fast moving faster is impossible. They can be with the same. The balls move to the right together. Yes, this is a possibility. But for that case, we need to have that what will happen. We need to know what will happen to their velocity. The white ball becomes stationary. Red ball move with to the right with the same speed, and the white ball moves to the left and red ball moves to the right. This is impossible situation. So here the final situation that we have, the white balls is going to be stationary, whereas red ball will move with the same speed, because this is an isolated system of the red ball. So here is all about our discussion. Whenever we are going to talk about law of conservation of momentum, so we have to consider that total momentum of an isolated system before and after is same. Sometimes we feel that these are not same. How it is possible? In that case, like when you fire from the rifle, when the skaters, ice skaters or roller skater push each other, in that case they are moving in opposite direction with equal amount of momentums. Maybe their velocity is different, but the product of velocity and mass will be the same. That is called momentum. I hope you guys understood the collision, isolated system, and also you got understanding about the law of conservation of momentum. Thank you so much, guys. Let us see about the types of momentum in our next video. Thank you and bye bye for now.